Alright guys, in this review we have included everything that we think could be on the final exam. Everything is mixed up there. It's not in any particular order, so it's really important that you're able to read the question, know exactly what to do wherever it's placed in the review. So let's get started. Alright, in this question you're given two different functions, f of x and g of x, and we are basically comparing them. We want to choose which of these statements are true. We do want to choose all that apply. So let's take a look. First choice, both f of x and g of x are increasing on the interval 0 to 2. First of all, let's look at f of x. If you see here, if we go left to right, which is how you're supposed to read the graph, I am increasing the entire way. If I do the same thing for g of x, left to right, I am increasing the entire way, which includes the interval from 0 to 2. So right now, we know that A is true. Let's look at B. F of x has a y-intercept at 1, while g of x has a y-intercept at negative 2. The y-intercept for f of x is, in fact, at 1, and the y-intercept for g of x is at negative 2. So this is also true. C, as x approaches negative infinity, so this is saying I'm going left on the graph, f of x is going down. So let's look at that one first, then we'll get to g of x. So again, as I go left, as my x's get smaller, as they decrease, my y's are going down towards negative infinity. So let's go left on this graph. As I go left on f of x, notice, first of all, hopefully you see that it's an exponential, and notice that as I go left, I start approaching this asymptote, which is at a y equals 0, and I never quite reach it. So unfortunately, it is not going to approach negative infinity. So it's not C. D, both f of x and g of x are positive across their entire domain. So let's take a look at these. I'm going to erase this just a little bit so we have a clean slate here. Let's look at f of x first. Alright, f of x, if I look across its entire domain, f of x is positive. The entire graph from negative infinity to positive infinity is above the x-axis. All of those y values are positive. However, if we look at g of x, if this is the x-axis, every single y value, until of course eventually the right side is going to increase and become positive, but there are plenty of values that are negative across this entire or much of its domain. So this one is not true either. E, as x approaches infinity, both f of x and g of x also approach infinity. So let's take a look at this one. As x approaches infinity, so as I go right, as my x's get bigger, both of them are going up, the y's are getting larger as well. So let's take a look at f of x first. As I go right, my y's are increasing, so that is true for f of x. Let's do g of x as well. As I read left to right, my y's are also increasing, so this is true. And then last one, f of x has a horizontal asymptote at y equals 0, and g of x has a vertical asymptote at x equals negative 1. So let's look at f of x. F of x does have that horizontal asymptote right here at y equals 0, so that's true. And g of x does have a vertical asymptote right here at x equals negative 1. That is also true. So we can also say that f is true. So it looks like A, B, E, and F are all true statements. The formula for the sum of a geometric sequence will be given to you on your formula sheet, but just as a reminder, that formula is that the sum for any n terms is equal to the first term times 1 plus the ratio, oops, I'm sorry, that is not 1 plus, let me erase that, 1 minus the ratio raised to the n all over 1 minus the ratio. So we've talked about this before. You need three things. You need the first term, you need the ratio, and you need n to figure out the sum. So in this one you want to find the first 7 terms, or the sum of the first 7 terms of the sequence that's given. We know pretty much everything with this one. This is the easiest case. We know that n is 7 because we're finding the sum of the first 7 terms. We know that our first term is 1. that's given to us, and we can figure out the ratio. So if we look at how we get from 1 to 1/2 by multiplying, some might say you're dividing by 2, which is true, but we have to think about what are we multiplying by. Dividing by 2 is the same as multiplying by 1/2. So it looks like our ratio is 1/2. Well, let's see if that works. 1 times 1/2, that is 1/2. 1/2 times another 1/2 is 1/4. Times another 1/2 is 1/8, so it does seem to work out. So when we plug into our formula, we get that our first term is 1 minus the ratio, which we said was 1/2, raised to the n, which we said was 7, all over 1 minus the ratio, which again is 1/2. Be careful with your parentheses. Do it step by step if you need to, but if you plug it in correctly, you should get that the sum of the first 7 terms is 1.984. The mean score on Mock 11 was 68% with a margin of error of 6.2%. Which test score is within its confidence interval? Confidence interval is just another way of asking what is that range of possible values and which of these scores falls within that range. So whenever you're given the margin of error, remember you're going to add and subtract that from your population mean. In this case, our mean was 68%. We want to add and subtract that margin of error of 6.2% to figure out our range. So if I take 68 and subtract 6.2, I get 61.8. If I take 68 and add 6.2, I get 74.2. So basically any value that is within this range, including the endpoints, would be within its confidence interval. So all we're doing here is looking to see which of these 4 values falls in that range, and it turns out that it is 63. All right, I've color-coded these steps for our step function here to help us with the values of the steps as well as their constraints. We want to write all the equations for each of the steps as well as the constraints that go with each step. So we're going to start with the red step first. It's really important that you remember that open circles mean there is not an equal to. Closed circles means there is. So if you specifically look here at our red step, we're going from x is equal to -9 to 5. Sorry, from -9 to -5. Our left is an open circle, right is closed. So this is going to be a compound inequality. We need to make sure there's not an equal to on the left, there is an equal to on the right. So if I were to write this as a constraint, it would be that my x's are between -9 and -5. Again, not equal to on the left, equal to on the right. If we do the same thing for the green piece, that piece is between between -5 and let's rewind for just a second. Let me clarify that first piece we did. So we started off here on the red piece. It goes between -9 and -5. Not equal to on the left because the left is open. Equal to on the right because it's closed. I actually meant to go to the purple step next, not the green. So let's take a look at the purple step. And I'm doing it in this order just because I'm going from decreasing y values to increasing. This particular y value for the red piece was y equals -9. Well, let's make it red. And then for the purple piece, we have y equals -7. Again, this is where it's crossing the y-axis. That's the value of our step. And then for the green piece, that's y equals 6. Okay, so going back, we just did the red piece. Let's look at the purple piece. Again, it's not equal to on the left, equal to on the right. These x's are ranging between -1 and +9. So my constraint should be that my x's are between -1 and +9. Again, it's not equal to and then equal to because of the circles. Last step is the step that is at y equals 6. That step ranges from -5 to -1, and its value is 6, as we said before. So its constraint is going to be from -5 to -1, and again not equal to because of the circles. So if we put this all together on a multiple choice question, it wouldn't be on top of the graph like this. So if we, more than likely it would be written some way like this. Starting, we'll go in the order that we did before. First piece has a value of -9. Its constraint is from -9 to -5. Second piece, the purple piece, had a value of -7, and its constraint was from -1 to 9. And then the last piece had a value of 6, and its constraint was that x's were between -5 and -1. And again, these could be in any order. You just have to make sure that you match the step to its correct value and constraint. Now we're moving to solving in this case we're solving a radical equation. One thing we need to remember when we do solve is that we check our solutions to make sure they work. Square root functions are one of the functions where you could have extraneous solutions. Alright, so in order to solve, just with anything, you want to isolate whatever it is you're trying to solve for. I want to solve for x. X is underneath the radical here. So I need to get that radical by itself so I can square both sides and undo the radical. So the very first thing I'm going to do is subtract 3 from both sides. That's going to give me the square root of x minus 1 equals x minus 3. Now I've got to undo the radical, so I'm going to square both sides. But remember, when I square a binomial, that is going, you have to expand it. So use the box method, whatever method that you like to multiply. When I square the left, the radical goes away and I have x minus 1 on the left. On the right, when I square x minus 3, I get x squared minus 6x plus 9. And now I have a quadratic here, so I'm pretty sure I'm going to have to factor, but remember it has to be set equal to 0. So I'm going to move that x in the -1. I'm going to subtract x. I'm going to add 1 to both sides. That gives me the 0 on the left, and then x squared minus 7x plus 10 on the right. Now this is a equals 1, so this is the easy factoring. I need to ask myself what two numbers multiply to give me 10, add to give me -7. Those two numbers are -5 and -2. So this factors into x minus 5 and x minus 2. First factor tells me that x equals 5. Second tells me that x equals 2. Now remember, you get those values by taking each factor and setting it equal to 0 and solving for x. Now, in this case, we do have an extraneous solution, and that extraneous solution is 2. All right, now it's not because it gives me a negative value. It is because when I plug it in, it gives me something that is not true. So let's take a look for just a second. All right, so I'm going to check x equals to 2. I'm going to plug in 2 everywhere I see an x. So that gives me 3 plus the square root of 2 minus 1 equals 2. 3 plus the square root of 1, which is 1, equals 2. We get 4 equals 2, but that is not a true statement. So because of that, we cannot say that x equals 2 is a solution. 5, however, does work. When you plug it in, you do get a true statement. So the solution to this equation is that x equals 5. Now you could also have put this in Desmos. If you put the left side as one graph, the right side as another, you should see that they cross in only one spot, and that is where x equals 5. Alright, solving log equations. Remember, if you're solving a log equation, unless we can use that special property where they cancel out, or not cancel out, where you disregard them, you're always going to have to convert to an exponential. So let's take a look at 6a. We've got, I'm going to rewrite it here just so we can have a clean slate. Log base 3 of 2x plus 1 minus log base 3 of 7 equals 2. Remember, you cannot have more than one log on a side. All right, so here we've got to condense first. We've got to condense both of those logs into one. Because there is a minus in the middle, because we have the difference of two logs, we have to condense it into a quotient. Remember, the negative term, the log with that is negative, what you're taking the log will go on the bottom, the other will go on the top. So when I condense the left side, I get log base 3 2x plus 1 should be on the top because its term was positive. 7 should be on the bottom because its term was negative, and then it still equals 2. At this point, we have the log by itself, so we can go ahead and we can convert to an exponential. Remember, you start at the base, go towards the equal sign. So it's going to be 3 to the second equals 2x plus 1 over 7. Again, that's 3 to the second equals 2x plus 1 over 7. We know that 3 to the second is 9. Oh, not 9 squared. It's 9. And that equals 2x plus 1 over 7. We want to move that 7 from the denominator by multiplying both sides by 7. That's going to give me that 63 equals 2x plus 1. Almost there. We're going to subtract 1 from both sides. That's going to give me 62 equals 2x, and then the last step is to divide by 2, and so that gives me that x is equal to 31. In 6b, you're also solving a log equation, but this is a natural log. You do not have more than one log on the side, so we don't have to worry about condensing. Again, I'm going to rewrite it just so I have some extra space. All right, now if you can move anything, you need to move it. I have got to move everything that is not this natural log, which means I've got to move the 4. So I'm going to divide by 4 on both sides. That gives me the natural log of 3x equals 3. At this point now I can convert. Remember, a natural log has a base of e, so I'm going to go ahead and put it there for clarity. I'm going to start the base, go towards the equal sign again. So it should be e raised to the third equals 3x. Again, that's e raised to the third equals 3x. The last step to solve for x is to divide both sides by 3. So you get x equals e cubed over 3. And if you put that in your calculator, you should get that the answer is 6.695, which is D. Now it's possible on the final that if you have this question, that they might leave it in exact form, in which case you just don't put it in your calculator and the answer would be e to the third e cubed divided by 3. All right, we've got another margin of error question. Polls for an upcoming election are in. Candidate A and candidate B have voter percentages of 46% and 54% with a margin of error of 7%. Can we use the poll to predict that candidate B is going to win? So right now it looks like he's going to, because he's got a percent, or she has got a percentage of 54%. Let's see if it is actually a good poll. So we're going to take each of the percentages, add and subtract the margin of error. The key here is that we want to look for an overlap. If there is an overlap, we cannot use the poll to predict it. If there is not an overlap, we can. So let's do that first. Let's look at candidate A. Candidate A has a 46% population mean. We're going to add and subtract that margin of error of 7. That's going to give me a range of values of 39 to 53. We're going to do the same thing. So again, this is for candidate A. For candidate B, we're going to do the same thing, but his percentage is 54%. We're going to add and subtract that 7. That gives us a range of 47 to 61. Now we need to determine if there is an overlap. All right, so I'm going to sort of do it on a number line without really doing it on a number line. Candidate A is 39 to 53. Candidate B is at 47, which is between 39 and 53. So I'm going to put 47 right here somewhere. And it's on the high range. Candidate B is at 61, which is after 53. So you can sort of see here that there's going to be an overlap somewhere right here. And because there is an overlap, we cannot predict that candidate B is going to win using this poll because of the overlap. So your answer in this case is B. There is an overlap in the voter percentages due to the margin of error. All right, in this case, the cost in dollars of enlarging a photo is given by the function, and the function is given to you, where W is the width of the enlargement in inches. Which function represents the inverse of the given situation? In other words, what is the width of, what is the equation written in terms of the width, and then we want to know what the width is for an enlargement that costs $58.75. First, notice that all your choices are solved for W, so that gives you a big clue as to what you need to do if you were confused. We need to take this equation, we need to take C equals 0.4 W cubed plus 2, and we need to solve for W. So we are needed to solve for W, but right now there's a bunch of stuff in the way of doing that. So we need to move everything that is not the W cubed over to the other side. That way we can eventually take the cube root to undo that cube and solve for W. So the very first thing that I'm going to do is I'm going to subtract 2 from both sides. That gives me C minus 2 equals 0.4 W cubed. I still need to move that 0.4. It's being multiplied by W cubed, so I'm going to divide by 0.4 on both sides. Now I've got C minus 2 over 0.4 equals W cubed. Now I've got the W cubed by itself, but I need to undo that cube. So I'm going to take the cube root of both sides. So that finally leaves me with an equation solved for in terms of W, and that equation is that W equals the cube root of C minus 2 over 0.4. So we can automatically cross out, well, we can automatically cross out none of them because, oh, I lied. We can cross out C and D because the root, the radical, the cube root is not around both of them. So it's between A and B, and the only difference is what the value is. So now we're going to plug in the value for cost. We know cost in this case is $58.75. So to find the width when you have that cost, we're just plugging in. Alright, so we're going to take the cube root of $58.75 minus 2 all over 0.4. So remember your order of operations. You need to do the inside of that radical first and then take the cube root. If you put it into your calculator correctly, you should get 5.2. So that gives us A. Moving on to systems of equations, we're in a situation where Jim has purchased 9 tickets to a concert and he spent $65 total. He purchased 2 types of tickets, children's tickets, which we're saying is going to be C, and adult tickets, which we're saying is going to be A. It's very, very, very important you're using the right variables here. So we are told that the children's tickets cost 5, so 5C. The adult tickets cost 10, so 10A. We also know that altogether he spent $65. So if we wrote that as an inequality, as a linear, or not an inequality, as an equality, the first one we know is related to cost. He spent $5 for each child's ticket, so 5C. He spent $10 for each adult ticket, so 10A, and altogether that gives us a total cost of $65. So that is one of our constraints that relates cost to children and adult tickets. Now if you look at your choices, automatically you can cross out C. That constraint is not, the variables do not correspond to the right costs. You can also cross out A. So we're basically now choosing between B and D, and the real difference between B and D is whether A plus C equals 65 or whether A plus C equals 9. In this case, let's go back to the question. It says that Jim purchased 9 tickets total. So that means that the number of children tickets plus the number of adult tickets has to equal 9. So that means our final answer is D. Alright guys, wherever possible we want to use our technology to help us, especially since you only have 75 minutes to take this final. In this one, Christopher determines that the system between S of x and T of x has only one solution. Which one is he solving? We do not expect you to solve these. If you look at them, they're kind of nasty. What we are expecting you to do